Hi everyone. In this video we are going to discuss about trigonometric equations in general, and also we are going to see how to solve some of the standard trigonometric equations. Before we go too far, let's first try to understand what a trigonometric equation is. We are already familiar with algebraic equations. For example, we could have an algebraic equation like this, and similar to this equation, how would a trigonometric equation look like? Well, it's kind of going to look like this. In the trigonometric equation, as you can see, the unknown variable x, it is actually inside a trigonometric ratio, meaning the equation itself is using trigonometric ratio of the unknown variable. So that is why this type of equations are called trigonometric equations. Here we can take another example. Let's suppose we could have an algebraic equation like this, 2 times x equals 1, and similar to this we could have a trigonometric equation that would look kind of like this. Here again you see that the equation has a trigonometric ratio of the unknown variable x. If we have an algebraic equation like this, for example, similar to this, we could also have a trigonometric equation like this. In this example, I am using the cosine instead of sine ratio, but that's okay. That is also another trigonometric ratio. The unknown variable is actually inside the trigonometric ratio. And some of the very standard trigonometric equations would be kind of like this. And in this video, we are going to see how to solve these standard trigonometric equations. Now, before we go into the detailed solution of trigonometric equations, we have to understand one basic concept in trigonometry, that the trigonometric functions are periodic functions. That means they have infinite number of solutions. And we are going to start our discussion based on the unit circle. I have already created several videos using the concept of unit circle, and here in this video also I am going to use unit circle as the foundation for the discussion of solving trigonometric equation. So now let's take a look at this unit circle that I have in the diagram. Let's assume that the radius of this circle is 1 unit, and we're going to assume the positive side of the x-axis as the initial ray, and the terminal ray can be something like this. I have shown the terminal ray in the pink color, and let's assume that the unit circle cuts the x-axis and the y-axis at these points, point A, B, C and D, and also let's assume that the origin is O. So if we assume OA as the terminal ray, and if we assume the positive x-axis as the initial ray, then if the terminal ray is at this position, then how much angle does it make with the positive side of the x-axis? Well, at this position obviously it is making 0 degree angle or 0 radian angle, because the terminal ray and the initial ray, they both are coincident, so they are making an angle of 0 degree or 0 radian between them, right? So now our discussion is on the position of the terminal ray when the ray is actually at position A. I mean when the terminal ray is OA, right? So we are now talking about the position A. Now for this position, as you can see, if we rotate this ray one full circle in the counterclockwise direction, now how much angle is it forming with the initial ray, which is the positive side of the x-axis? Well, obviously this will be 0 plus 2 pi. So initially we started with 0, and now we are seeing that it is making 0 plus 2 pi angle. Now going forward, we will be talking about the angles in terms of radian, in the radian unit, not in the degree unit. So we will be talking about radians only. Now if we rotate it one more time in the counterclockwise direction, then it will be making 0 plus 4 pi, that much angle. And now I am going to rotate it in the clockwise direction. And if we rotate it in the clockwise direction one full circle, then what would be the angle? The angle would be 0 minus 2 pi. And if we rotate it one more full circle in the clockwise direction, then what will be the angle? Now the angle would be 0 minus 4 pi. And we can keep on doing like this, and you are starting to see a pattern already, right? So here, if we had rotated it one more time counterclockwise, it would have been 0 plus 6 pi. And again, if we rotated the ray in the clockwise direction one more full circle, then it would be 0 minus 6 pi. So here we can see a pattern already that looks like when the terminal ray, which is OA, is at this position, then it is making an angle of 0 plus some even multiple of pi. So we can say at position A, the angle that it is forming, it is actually 0 plus some even multiple of pi, and that even multiple could be a positive even multiple or a negative even multiple, but it's just an even multiple of pi. So can we write it like this then? We can write it as 0 plus 2 times n times pi, when n could be any integer, positive or negative. I have noted that as n belonging to the integer set. So whether n is 0 or positive 1 or negative 1 or positive 2 or negative 2 does not matter. We will always get an even multiple of pi, and if we want to write it in a simpler form, we can write it like this. We can simply remove the 0 and we can say, well, when the terminal ray is at the position A, which means the terminal ray is OA, at that position the angle that it makes with the positive side of x-axis would be 2n pi. And that's a very important information. We need to make a note of this and I'm going to highlight it. And similarly, we are going to try and find out what would be the angle that the terminal ray would create with the positive side of x-axis when the ray is at the position B. I mean, when the ray becomes OB, then what will be the angle between positive side of the x-axis and the terminal ray? Let me quickly draw the terminal ray here. Now let's suppose we have the terminal ray at this position. We want to find out how much angle it's making with the positive side of the x-axis. So now we are talking about the position B. Let me highlight that. While the terminal ray is at this position, you can see that originally it's already making an angle of pi over 2, and then if we rotate it counterclockwise one full circle, then it would make pi over 2 plus 2 pi, that much angle. If we rotate it one more time in the counterclockwise direction, it will make pi over 2 plus 4 pi, and if we rotate it one more time, it will make pi over 2 plus 6 pi. And similarly, from the initial position, if we rotate it in the clockwise direction one full circle, then it's going to make an angle like this. It would be pi over 2 minus 2 pi, and if we rotate it one more time in the clockwise direction, it will make an angle of pi over 2 minus 4 pi, and similarly if we rotate it one more time in the clockwise direction, it will make an angle of pi over 2 minus 6 pi. So here again we see a pattern that it's actually making an angle which is pi over 2 plus or minus an even multiple of pi. So then can we write it like this? We can say, well, this angle is looking like pi over 2 plus or minus some even multiple of pi, and this can be written as pi over 2 plus 2n pi, where n is an integer. It could be a positive integer or negative integer or 0. And if we simplify a little bit, it's going to look like 4n plus 1 times pi over 2. So let me make the final note here. Next we are going to talk about the position C, I mean when the terminal side is at position C. At this position, what is the initial angle? Well, the initial angle is actually pi, and then if we rotate this ray one full circle in the counterclockwise direction, it's going to make pi plus 2 pi angle with the positive side of the x-axis, and if we rotate one more time, it's going to make pi plus 4 pi angle. If we rotate one more time, it's going to make pi plus 6 pi angle. And similarly, if we rotate it in the clockwise direction from the initial position, if we rotate it in the clockwise direction, then it's going to make pi minus 2 pi angle. And similarly, one more full rotation in the clockwise direction will give pi minus 4 pi angle. And one more rotation in the clockwise direction will give pi minus 6 pi angle. So here again we are starting to see a pattern, and the pattern is that it's looking like pi plus or minus an even multiple of pi. So we can make a note like this. It is going to be pi, then plus or minus an even multiple of pi. So can we write it like this? We can say then pi plus 2n pi, where n can be any integer, can be positive integer, negative integer or 0, and that's going to look kind of like this: 2n plus 1 times pi, and n is an integer of course. So let me make the final note here. Next we are going to talk about the position D. When the terminal ray is at position D, I mean the ray itself is OD, then what is the initial angle that it's making with the positive side of the x-axis? Well, you can think of it in two different ways, right? You can think of it as a positive 3 pi over 2 or a negative pi over 2. I mean, if you look at it like this, this is actually positive 3 pi over 2. But if you look at it like this will be negative pi over 2. And here if we use the negative pi over 2 as the initial angle, then the final formula will actually look similar to the one for position B. So let's proceed with negative pi over 2 as the initial angle, right? And then if we rotate it in the counterclockwise direction one full circle, then the amount of angle between this ray and the positive x-axis would be negative pi over 2 plus 2 pi. And similarly, if we rotate it one more time in the counterclockwise direction, it will be negative pi over 2 plus 4 pi. And similarly, from the initial position, if we rotate it in the clockwise direction one full circle, then the amount of angle would be negative pi over 2 minus 2 pi. And if we rotate it one more time in the clockwise direction, the angle would be negative pi over 2 minus 4 pi. So here again we are starting to see a pattern that the angle is looking like negative pi over 2 plus or minus an even multiple of pi. So we can write it as negative pi over 2 plus 2n pi, where n can be any integer, positive or negative or 0. And if we simplify this a little bit, we can write it as 4n minus 1 times pi over 2. And that is the form that I was looking for, because now if you look at it, you will see that it looks pretty similar to the angle that we obtained at position B. At position B, the amount of angle was 4n plus 1 times pi over 2, and at position D, it's actually 4n minus 1 times pi over 2. So let's make the final note. Now let's analyze the value of sine ratio and cosine ratio for each of these positions. When the terminal ray is at position A on this unit circle, we know that sine ratio is represented by the y coordinate of the point of intersection of the ray and the unit circle. In this case, it is the point A that we are talking about. So at this point, what is the value of the sine ratio? Well, sine ratio is actually the y coordinate of that point, and cosine ratio is actually the x coordinate of that point. I have already posted a detailed video on the concept of unit circle. I have provided the link in the description. Feel free to watch that video. So at position A, the value of sine function is actually 0, because the y coordinate is 0 at the point A. The y coordinate of point A would be 0 and the x coordinate of point A would be 1. That means the cosine function at this position would be 1, which is the x coordinate, and the sine function would be 0, which is the y coordinate. So I'm going to make the note like this. Now if we assume that this ray is making an angle of x radian with the positive direction of x-axis, then we can say sine of x would be equal to 0, which is the y coordinate of the point A, and cosine of x would be equal to 1, which is the x coordinate of the point A. And because it is a unit circle, obviously the length of OA would be 1, so the x coordinate of point would be 1 and y coordinate would be 0. So we can say sine of x would be equal to 0 and cosine of x would be equal to 1. Now let's talk about the position B. Well, the coordinates of B are actually 0, 1. So the sine function of that angle would be 1 and the cosine function would be 0. Here again we are assuming that the ray is making an angle of x radian with the positive direction of x-axis, and with that assumption sine of x would be equal to 1 and cosine of x would be equal to 0. Now let's talk about the position C. The coordinates of point C are actually negative 1, 0. The x coordinate is negative 1 and y coordinate is 0. So sine of x would be 0 and cosine of x would be negative 1. And again with the same assumption that the position of the ray is making an angle of x radian with the positive direction of the x-axis. And finally, let's talk about the position D. When the ray is at position D and if it is making an angle of x radian with the positive direction of x-axis, here the coordinates of D would be 0, negative 1. That means the x coordinate would be 0 and the y coordinate would be negative 1. So we can say that sine of x would be negative 1 and cosine of x would be 0. I hope things are clear up to this point. Now let's try to find out what would be the general solution of sine of x equals 0, this equation sine of x equals 0. From the diagram you can see that sine of x could become 0 at two positions, position A and position C. So when the ray is at position A or at position C, the sine function of that angle would be 0. Now what are the general representation of the angles at position A and position C? Well, at position A the angle is 2n pi where n is an integer, and at position C the angle is 2n plus 1 times pi when n is an integer. Right? So sine function becoming 0 gives us two possibilities. Either the angle is 2n pi or 2n plus 1 times pi. So sine function is 0 at position A. So let me make a quick note right here. So if we have to solve this equation, which is sine of x equals 0, assuming x is an angle in radians, so it is possible at position A and also at position C. Now what is the general form of the angle at position A? Well, that is actually 2n pi. And what is the general form of the angle at position C? Well, that is actually 2n plus 1 times pi. And now if you think about this combined picture here, I have enclosed that in a green box. If you look at that combined picture, you see that the angle could be an even multiple of pi or an odd multiple of pi, because 2n would give us an even number and 2n plus 1 will give us an odd number. So this angle can be an even multiple of pi or an odd multiple of pi. That means, can we say that, well, then it would be any integral multiple of pi, whether the integer is an even number or an odd number? Yes, of course we can say that. So an even multiple of pi and an odd multiple of pi combined together will give us a general solution of just an integral multiple of pi. So we can write this as n pi, where n is an integer. So any integral multiple of pi would give us the value of the sine ratio as 0. So let me make a final note here. So whenever the value of the sine function of an angle is 0, that angle could be any multiple of pi. It could be 0 multiple of pi, it could be positive 1 multiple of pi, it could be negative 1 multiple of pi, it could be positive 2 multiples of pi, it could be negative 2 multiples of pi. So it could be any multiple of pi, right? And that is called the general solution. So in this case, you can see that sine of x is equal to 0. Obviously, one of the solutions is x equals 0 radian. That is obviously one of the solutions. However, that is not the only solution. Because these are periodic functions, we have infinite number of solutions, and the way we represent that infinite number of solutions is actually in this form, where I have written x equals n pi, where n is an integer, and this is called the general solution. This particular form, where we use an integer n to represent the set of solutions, this is called the general form of the solution. Now let's try to find out what would be the solution when cosine of x is equal to 0. As you can see in the diagram, cosine of x could be 0 only at two positions, at position B and position D. So let me make a note here. So cosine of x could become 0 at position B and position D. Now what is the amount of angle when the ray is at position B? I have the summary note up here on the top right corner. So at position B, the amount of angle is 4n plus 1 times pi over 2. And when the ray is at position D, the amount of angle there is actually 4n minus 1 times pi over 2. And if you look at the combined picture here, I mean the two sets of angles here, you will realize that it is actually an odd multiple of pi over 2, because 4n plus 1 will always give us an odd number, 4n minus 1 will also always give us an odd number. So it is nothing but an odd multiple of pi over 2. So can we write it as an odd number, let's say 2n plus 1 times pi over 2? That can be a simpler representation of these two angles combined together. So at position B and D, we are actually getting an angle which is an odd multiple of pi over 2. So let me make the summary note here. So we have finally found the general solution when cosine of x equals 0. The general solution x is equal to an odd multiple of pi over 2. So we can write it as 2n plus 1 times pi over 2, where n is an integer. Any integer could be 0, positive or negative. And in fact, you can try with different values of n, and you will see that all the angles that you will be getting as a value of x, they all will turn out to be odd multiples of pi over 2. Next, let's talk about the trigonometric equation sine of x equals 1. I am writing it at the bottom left hand side of the screen. From the diagram, we can see that sine x can be equal to 1 only at one position, which is the position B. And what is the amount of angle at position B? Well, the general formula for the amount of angle at position B is actually 4n plus 1 times pi over 2. So then, what would be the solution in this case? Well, in this case, it's pretty easy. It's only one set of solution, that would be 4n plus 1 times pi over 2. Next, let's try to solve the trigonometric equation, which is cosine of x equals 1. As you can see in the diagram, there is only one position at which cosine of x can be 1, and that is the position A. And what is the general formula for the amount of angle at position A? Well, that would be equal to 2n pi. So then we can say that x would be equal to 2n pi, where n is an integer. Next, we are going to see where sine x could be negative 1. Well, from the diagram, we can see that sine of x can be negative 1 only at one position, and that is the position D. And the amount of angle for position D is actually 4n minus 1 times pi over 2. So when sine of x is negative 1, we can say that x would be equal to 4n minus 1 times pi over 2. And similarly, let's take a look at the trigonometric equation cosine of x equals -1. From the unit circle diagram, we can see that cosine of x can be equal to -1 only at one position, and that is the position C. And the general formula for the amount of angle at position C is actually 2n plus 1 times pi. The 6 trigonometric equations that we just reviewed, they are the fundamental trigonometric equations. In fact, all the solutions that I have denoted here in the pink color, they all are in the general form. We call them the general solution, which actually covers the entire set of solution, and you can find each of the solutions by taking a value for n as an integer. It can be positive numbers, negative numbers, as well as 0. So you can assign different values to n, and thereby you can find each of the solutions. But if we have to write the solution in the general form, then these are the general forms of the solution sets for these 6 fundamental trigonometric equations. If you are ever asked to find out the general solution, or if you are asked to write the general solution of a trigonometric equation, you are going to write the solutions like this, and that is called the general solutions. So let me make a note here that all of these solutions are actually denoted in the general solution form. Apart from the general solution, there is also another type of solution which is called the principal solution. Now let's make a quick note first. So we'll discuss about the principal solution. Now let's see how we can find the principal solution. First, we have to understand what is the principal solution. Well, the principal solution is the set of solution between 0 to 2 pi. This solution actually belongs to the interval, so I can write it here like this. We can say that this solution, the principal solution, actually belongs to the interval which is 0 to 2 pi and 2 pi excluded. 0 included but 2 pi excluded. So between 0 to 2 pi, whatever solutions we find, they will be called principal solutions. Now let's take an example. Let's suppose we take the solution set which is sine of x equals 0, and in that case x is equal to n pi. So when sine of x is equal to 0, let me write it over here, x is equal to n pi, where n is an integer. Now let's use different values of n, right? First let's try 0. When n equals 0, x will be equal to 0 times pi, that is 0. When n equals 1, let's use positive 1. X would be equal to pi. When n is equal to 2, x will be equal to 2 pi. So in this case, the principal solution would be 0 and pi, because 2 pi is not included in the principal solution, but 0 is included. So this will be the principal solution. Right here, let me highlight this, that these two values, 0 and pi, that will be the principal solution. So here, if we have to write down the principal solution for this particular trigonometric equation, we can say that x is equal to 0 or pi. Using set notation, we can write it as x belongs to the set of two numbers 0, pi. And you can practice this way. You can try different values of n to find the principal solution. Only thing you have to remember is that that solution has to be between 0 to 2 pi, and 2 pi not included, of course. I hope everything made sense. Thank you for watching. See you in the next video.